Welcome to Dev Trends on the Go. Today's Qiita picks for June 12th, 2026.
Yeah, the perfect quick listen for your morning commute or, just whenever you have some downtime.
Exactly. And for our global listeners who might be tuning in, Qiita is basically the Japanese developer community's version of Dev.to or Medium.
Right. It's this massive knowledge sharing platform where software engineers just post like the raw, unfiltered realities of what they're actually building or
There
breaking
you
at
go.
work.
Yeah, it's super practical. Oh, and real quick, before we get into the trending articles, please take a second to hit subscribe and like on your podcast app.
Yeah, it takes 2 seconds and it really helps us keep bringing you these daily updates.
Awesome. So, looking at the feeds today, there's a lot of variety. Like, there's a post about someone grinding out 12 AWS certs in a year.
Which is just wild,
Yeah,
honestly.
completely bonkers.
Yeah.
And some tutorials on Cloudflare Zero Trust. And this really palpable collective joy over finally getting native border decorations for CSS Flex and grid gaps.
Oh man, front-end devs have been waiting like a decade for that. It's a huge deal.
I know, right? But beneath all of that, there's one massive theme just dominating the conversation today, and that is the actual on-the-ground reality of AI-driven development.
Yeah, specifically coding agents. We are moving way past the honeymoon phase of AI.
Totally. So today's rundown is all about cutting through the hype. We're looking at how these AIs actually read your code, how they are quietly draining your wallet, and how your actual job description as an engineer is fundamentally changing right now.
And I think a great place to start is this fascinating study trending on Qiita about how AI agents hunt for context. Because, we have this illusion that you just drop an AI into a repo and it magically understands everything.
Right, like it just plugs in, Matrix style, and knows all 50,000 lines of code instantly.
Exactly, but that's entirely false. They have to actively read it. So researchers took 7 different leading coding agents and threw them at a real project with 338 files.
Okay, so that's way too big for a standard context window. They can't just memorize it.
No, they have to search. And the study breaks down 5 distinct ways they do this. The first is lexical search, which is basically just running a grep command.
So just old school exact keyword matching.
Right. Then there's semantic search. This relies on vector embeddings and RG.
And just to clarify the jargon for anyone listening, RG basically just means letting the AI read relevant reference material before it tries to answer, right?
Spot on. It converts the code into math, basically, so it searches by meaning. Third is structural search, which reads the abstract syntax tree.
Okay, the AST.
Yeah. Fourth is agentic search, where the AI actually gets an interactive terminal and types shell commands on the fly. And finally, multi-agent search, where a manager AI delegates to sub-agents.
Okay, so 5 different ways to look for code. Who is this study actually useful for?
Honestly, it's incredibly useful for anyone trying to set up local AI agents for their team because the efficiency differences are massive, especially when you look at Claude Code.
Right, the Anthropic model. What did they do?
Well, Anthropic completely abandoned the semantic search method. They dropped embeddings entirely.
Wait, really? Because semantic search is, like, marketed as the gold standard for AI right now?
It is. But the Qiita post explains why. If you use semantic search, it's like building a highly detailed 3D map of a massive library just to find one book.
And I'm guessing the map gets outdated fast.
Exactly. Every time a dev refactors a function, the map is stale. Rebuilding it costs tons of compute, and scanning an enterprise codebase for it is a security nightmare.
Okay, so if Claude isn't building a 3D map, what is it doing? Agentic search.
Yep, it goes all in on agentic search.
So keeping with the library analogy, that's like sending a highly caffeinated intern running frantically through the physical aisles, just pulling books off shelves and guessing where things are.
That is exactly what it is, and it's wildly inefficient.
I mean, if it's just guessing search terms in a terminal, doesn't that waste a massive amount of energy?
It does. And that was the critical takeaway from the researchers. All the agents completed the exact same coding task, but the token consumption was night and day.
How big of a difference were we talking?
Well, a tool called Aider, which uses structural search, meaning it just reads the rigid skeleton of the code and ignores all the text and comments used between 8 and 13,000 tokens.
Okay, about 10,000 tokens. And Claude Code.
Claude burned through up to 117,000 tokens for the exact same task.
Holy wait, 117,000. Why so many?
Because every time that digital intern runs an else command, the terminal spits back 50 lines of directories. The AI reads it, thinks, then runs a cat command, gets 200 lines of config text, reads that.
Oh, I see. And every single character in that back and forth loop is eating up input and output tokens.
Exactly. Which brings us to the next massive trend on Qiita right now, taming the token monster.
Yeah, this is super relevant for independent devs or freelancers who are literally paying their own API bills out of pocket.
Absolutely. Because if you let Claude run wild, you will hit your API rate limits in a few hours. So the community is building custom diet tools for the AI.
Like that one tool mentioned in the sources, RTK.
Yeah, RTK is brilliant. It intercepts the shell commands the AI runs before the data actually gets sent back to the language model.
So it basically strips out all the useless terminal formatting, right? Like
Yeah,
syntax colors, extra white space, redundant file paths.
exactly. Just raw data. One developer reported that RTK saved them 2.1 million input tokens. That's a 76% reduction.
That is huge. A 76% discount on your API bill just for removing white space. And there's another tool for the output side too called Caveman.
Right. Caveman specifically targets Claude Code to stop it from being so polite.
Yeah, it basically forces the AI to act like a robot. Instead of it saying, I have analyzed your error and here's the JSON, it just outputs the JSON block. Nothing else.
And that dropped output tokens by 65%.
But, I always wonder, if I'm paying top dollar for an advanced reasoning engine, why do I have to install a script called Caveman to teach it not to say please and thank you?
It comes down to how these base models are trained. They go through massive reinforcement learning from human feedback. They are trained to be chatty and universally helpful.
Right, because that's what a normal person wants in a web browser interface.
Exactly. But when an AI is running iterative loops in your terminal, like trying 20 different debug commands in the background, saying a polite greeting on every single loop becomes a literal financial liability.
Yeah, that makes total sense. People are getting so anxious about costs that they're using a MUX, a terminal multiplexer, to run daemon scripts that just constantly show their API billing limits on screen.
Imagine having a ticking taximeter on your screen while you code. It's stressful.
Super stressful. And this actually ties perfectly into the next article, which looks at the bleeding edge of AI models, specifically Anthropic's new Fable 5 versus the current workhorse, Opus 4.8.
Yeah, this is a great breakdown, especially useful for tech leads or engineering managers who have to decide which model to actually deploy for their teams.
Right, because Fable 5 is undeniably powerful. It has this intense autonomy, like if you give it a bug, it doesn't just check your files. It might spontaneously realize your coworker is doing related work, pull their unmerged branch, and cross-reference everything.
Which is an incredible architectural leap. The reasoning required to do that without breaking is massive.
There's always a but.
Yeah. The cost of that deep reasoning is time. The Deep Suite benchmarks showed Fable 5 taking over 90 minutes to complete long-form tasks.
Wow. And how long did the older model, Opus 4.8, take for the exact same task?
Between 12 and 34 minutes.
Oh, man. So it's like a brilliant but incredibly overzealous detective. Opus 4.8 just checks the security camera and finds the stolen bike. Fable 5 interviews every single neighbor in a 3-mile radius and hands you a 100-page dossier.
That is the perfect analogy. You get the bike back, but you wasted the whole day. Plus, Fable 5 generates about 15 to 20% more comments during code review.
Which brings us right back to the token monster.
Yep, and it also brings up something developers call cognitive complexity.
Oh, right. We usually measure that for human code, right? Like using tools like PHP Stan and GitHub Actions to flag functions that are just too messy for a human brain to trace.
Exactly. If the AI takes 90 minutes and generates a massive wall of overly thorough text and extra comments, it fails that human complexity test. It's just noise.
So if we have these hyper-autonomous agents that want to read everything, pull coworker branches, and write too much, how do we actually put a leash on them?
That is where the Qiita community is pivoting to these new architectural frameworks. Two major ones are getting a lot of traction, OpenSpec and MCP.
Let's start with OpenSpec. This is great for architecture teams trying to automate safely. It uses Gherkin syntax, right?
Right. Instead of just telling the AI, build a login page and letting it write code immediately, you force it to use Gherkin.
Which is that given, when, then format. Like given a logged in user, when they click checkout, then the card updates. Plain language, but strict.
Exactly. So the AI has to process your request and generate a delta spec first. It's basically a proposal of exactly what files it wants to change.
So it creates a mandatory human checkpoint. You review the spec, and if it looks good, then you let the AI generate the code.
Right. It stops the AI from wandering off into the weeds. And the second framework is MCP, the Model Context Protocol.
Oh, I've been seeing MCP everywhere.
It's essentially a standardized bridge that dictates exactly which external tools the AI is allowed to touch.
The examples and the sources are so cool. Like someone used Microsoft Foundry to build an MCP server for a cupcake shop. The AI checks live inventory and handles physical orders.
Yeah, and the Japanese sources highlight a really sensitive use case with a cloud accounting software called Free.
Oh yeah, they built an MCP integration where the AI reads a messy spreadsheet and automatically hits the accounting API to draft invoices.
Which naturally makes a lot of engineers nervous.
Seriously. Yeah. I mean, there's that Japanese tech jargon they mentioned, unyu de cover, which basically translates to operation cover.
Right. It's that dark joke where the system is flawed, so you just rely on manual human effort to prevent a disaster.
Yeah, and letting an AI directly touch your company's live accounting software feels like the ultimate unyu de cover risk. What if it hallucinates an extra zero?
Well, that's the beauty of MCP. It actually flips the risk model. It makes the AI the interface, not the decision maker.
Wait, how does it do that?
When the AI hits the accounting API, it doesn't have the permissions to finalize anything. It just drafts the invoice. A human accountant still has to log in, review the draft, and manually click approve.
Oh, I see. So the AI does the tedious data entry, but the human holds the keys to the execution? You don't need to know the software's weird menus anymore. You just need to know how to review the work.
Exactly, which honestly leads us to the biggest existential question for everyone listening today.
Right. If the AI is reading the code base, drafting the architecture with OpenSpec, and formatting invoices with MCP, what is the actual job of a human engineer now?
The Japanese community is rallying around this concept called the 4D framework. It's basically the new skill set for the generative AI era.
Yeah, this is crucial for literally anyone writing code today.
Yeah.
Let's break down the 4Ds. What's the first one?
Delegation. Knowing exactly where to draw the line. What is a good task for an LLM's pattern recognition, and what requires human intuition?
Like, let the AI write the unit tests, but you decide the security architecture.
Exactly. The second D is description. Can you provide the exact context, constraints, and edge cases the AI needs so it doesn't hallucinate?
Makes sense. And the third is discernment. When the AI spits out code, can you actually evaluate it?
Right. You can't just swallow the first draft whole. You have to spot the subtle flaws. And the fourth D is diligence.
Taking ultimate responsibility.
Yeah, unglamorous but true. You can blame the AI for writing a bug, but you're the one who approved the pull request.
What I thought was really interesting is how the sources connected this to a soft skill. They called it kiku jujutsu, which is basically active listening.
It's so true, though. Knowing when to stay silent in a meeting, how to read between the lines of what a client actually wants versus what they say they want.
Because if you can't listen and extract the real context from a human, you can't write a good description for an AI.
It completely changes the career path.
It really does. I mean, looking at delegation, description, discernment, and diligence, it sounds like every junior developer is basically being promoted to management on day one.
Pretty much. Your job is now managing a team of very fast, slightly chaotic digital interns.
But the sources had a warning about that, right?
Yeah.
That classic Japanese developer joke, kanzen ni rikai shita.
Oh, yeah. It means I completely understand, but developers usually say it sarcastically when they actually have absolutely no clue how the system works.
We've all been there. Nodding in a meeting, silently panicking.
But you can't fake it anymore. Even as a manager of AI, the underlying technical foundation knowing Git, Linux, SQL, Docker is completely non-negotiable.
Because without it, you don't have that third D. You have no discernment.
Precisely. When the AI confidently hallucinates a bad database query, you have to be the one to catch it. The market isn't paying for someone who can type a sorting algorithm fast anymore.
Right. They're paying for someone who can use AI to build an MVP in a weekend and then actually take responsibility for keeping it stable.
So just to quickly recap today's rundown, we have to stop assuming AI magically knows our code. It uses expensive agentic searches that burn tokens.
Yeah, and we're fighting back with tools like RTK and Caveman to strip out the fluff and silence the AI's politeness.
We're seeing models like Fable 5 getting a bit too thorough, pushing cognitive complexity too high.
And we're managing all of this with OpenSpec for structured code generation, MCP for safe tool use, and the new 4D framework for our own careers.
It is a massive shift in how we build software. But, before we sign off, there is one last thought I want to throw out there based on all this.
Oh, what's that?
Right now, we're relying on manual stuff like Caveman and OpenSpec to constrain these AIs. But as they iterate and eventually learn to optimize their own token usage and write their own perfect specs,
Okay, yeah.
will our 4D management framework even be enough? Or are we going to have to invent an entirely new, higher-level language of logic just to communicate abstract goals to systems that manage themselves?
Wow. So we're just building the interns that will eventually become the managers. That is wild to think about.
It really is.
Well, that's a lot to mull over. Take a look at your workflows today and ask yourself, what tedious task can you delegate to your digital intern tomorrow?
Thanks for tuning in. Please don't forget to subscribe, and we'll be back tomorrow with another episode.
Have a great day and happy coding.